this video we have an example problem where a gas is initially has a certain volume and then a certain pressure, and then the gas expands to a certain volume but the pressure decreases, and we want to know what the work done to the gas is. Now, nowhere in the problem does it mention that anything is held constant, and when I draw my two data points to connect the line, there's no indication that it should be a curvy line like it's isothermal or adiabatic, and it's definitely not horizontal like isothermal or vertical like isovolumetric. That means that this is a general case in which we need to, in order to find the work done, find the area underneath the curve. So the first thing you'll notice here is that I plotted my two data points, and then I've defined my area under the curve by drawing two vertical lines. And then I have my two areas, my triangle and my rectangle. So I've written down work equals 1/2 base times height, which is the area of the triangle, and length times width, which is the area of the rectangle. So we have 1/2 times base. The base is going to be between the two volumes, and notice I'm doing the subtraction so that it's positive. And then the height, here it's defined by the two pressures. Once again, I'm subtracting so it's positive. Now I can do the rectangle. One dimension is defined once again by a volume, and I'm doing the subtraction so it's positive. Now the other side is a little bit tricky because you're going from the 1500 pascals down to the x-axis where the pressure equals 0. So it would be 1500 pascals minus 0. I'm now able to calculate my work. So I have the work from the portion that's triangle shaped, I have the work from the portion that is rectangular shaped, and I add them together. And notice I made it minus sign because the volume of the gas increases, meaning the work done is negative. So don't forget to go back and apply your sign rules that we learned at the beginning of this particular section.